important thing, a vector which has unit magnitude and which points in any convenient direction. And the three convenient directions are the three basic directions that we use to represent any direction in three-dimensional space are x, y, and z axis, positive and negative. Okay, so these are the three fundamental dimensions, directions, combination of which gives you any possible direction. And the unit vector which points along positive x direction is I cap, along positive y direction is j cap, positive z direction is k cap, and negative x direction is minus I cap, negative y direction is minus j cap, negative z direction is minus k cap. So I cap, j cap, k cap are unit vectors along x, y, and z axis. Okay, then using these unit vectors, how can we write a vector? Suppose if I write a vector like vector A equal to 2i plus 3j plus 4k, then it means that this vector A has magnitude in three directions, along I, along j, and along k. Along I, its value is 2, along j, its value is 3, along k, its value is 4. This is the representation, standard representation of a vector in terms of I, j, k unit vectors. Right. Then last one, null vector. Null means zero, nothing. So a vector which has zero magnitude and whose direction is indeterminate. Indeterminate means which cannot be known or which we don't know. We call such a vector as a null vector. So null vector is kind of zero in vector algebra.
Sir, what can be the example for null vector, sir?
See, here you can take an example. Suppose if I have vector A is equal to 4i cap and vector B is equal to minus 4i cap. Then if I add these two vectors, vector A plus vector B, I get 4i cap minus 4i cap, which is a null vector. 0, but we read it as null vector.
Sir,
Right. After this,
sir,
uh,
sir, can we write like a zero vector also?
no.
Null vector.
If you wish, you can put a bar arrow mark over it. It is to be read as null vector. Right. See, next after this, the next topic is magnitude of a vector
Sir, how is null vector represented?
with a 0. Magnitude of a vector. Okay. Or for right, I think you better you have it, you get this clarity. Then we will discuss this null vector. See, positive x-axis, negative x-axis, positive y, negative y. If I draw a vector like this is vector P. Vector P. Can I represent vector P as xi plus yj? Xi plus yj. What does this mean? This means
No, sir, we have to keep the cap.
even if you don't keep the cap, it's understood. I told in the last class itself, every time it's not convenient to put the caps while writing. So if you even ignore the cap, just by looking at I, J, K, you should understand that they are unit vectors. If there is cap, okay. If there is also no cap, no problem. I, J, K are unit vectors, standard notation. So vector P, it is having magnitude both along x and y directions. Its magnitude along x direction is this much. And its magnitude along y direction is this much. I'm calling it as small x and small. So in vector notation, I will write vector P as xi plus yj. This xi plus yj, let's take some example, 2i plus 3j, 4i plus 8j, something like that. X can be any number, y can be any number. Okay, vector P. If I take vector Q, which is like this is vector Q. So we can see here, vector Q has magnitude along negative x direction, which is this much. Okay, I'll call it, okay, so let us say same magnitude is same, x along negative x direction. And along y, it is the same thing, y. So can I write vector Q as minus xi plus yj, minus xi plus yj. If I take another vector r, this is vector r, its value, its magnitude along x direction is this much, same x, and its value along y direction is this much. So vector r can be written as minus xi
minus yj.
minus yj. Next, another vector s. This is vector s, and its value along x direction is this much, and its value along y direction is this much. So
Plus
I can write vector s as x is positive, y is negative, xi
minus yj.
Okay, so just by looking at a vector and its components, x, y are components of a vector along I direction and j direction respectively. So by looking at a vector, you should understand what is its orientation. What is its orientation, or what is its direction? How much is its value along x direction? How much is its value along y direction? You must be able to understand all these things. This is in 2 dimensions, xy plane. You can have vectors in x, y, z, 3 dimensions also. Suppose if I write a vector A, if a vector A is written as xi plus yj plus zk, what does this mean? This means the value of vector A along direction of I is x, or value means magnitude. Magnitude along I direction. And this is yj means magnitude of vector A along j direction, and z means magnitude of vector A along k direction, xi plus yj plus zk. Suppose vector I is like this, 2i plus 2j plus 2k. So 2 units along x direction, 2 units along y direction, 2 units along z direction. Or vector A can be minus 2i plus 2j plus 2k. Or vector A can be minus 2i minus 2j minus 2k. It can be anything. So depending on that, it's just like finding directions, right? Finding in the path. Start from here, go straight, take left, then go straight, turn right, take a U-turn, like that. So by looking at each term of the vector, you should understand that you should imagine that you are going in that particular direction by that much magnitude. 2a plus 2j plus 2k. Start from origin, go towards right 2 units, then turn to your left, go along y direction 2 units, then along z direction go 2 units. You should be able to visualize in 3 dimensions. Minus 2a plus 2j plus 2k. Minus 2a. So start from origin, go towards negative x-axis 2 units, toward positive y-axis 2 units, towards positive z-axis 2 units. That's how that vector will be. Okay, so this is how we represent a vector using unit vectors. And we call this form of this representation of a vector in terms of ijk unit vectors is called component form. The form of representing a vector using ijk unit vectors is called component form. Okay, because these are the 3 components of that vector along 3 different directions. Right. So after understanding unit vectors and what does a vector represented unit vectors means, now we can understand what is magnitude of a vector, how to find out magnitude of a vector. Magnitude of a vector.
Sir,
Hmm.
can you once scroll up? Sir, can you explain the example once again?
Which example?
Second one, sir.
2i plus 2j plus 2k. What do you understand from this thing, from this vector? 2i plus 2j plus 2k. 2i plus 2j plus 2k. What do you understand from 2i?
Sir, two perpendicular from y-axis.
Uh, See, every vector
Sir,
tells you 2 things. Every vector tells you 2 things. One is magnitude, other is direction. So 2i is also a vector quantity. This quantity tells you, this vector tells you that 2 is its magnitude and its direction is I. And I hope you understand direction of I means positive x-axis. So you should go in this direction. How much? This much. 2. So you start from here, go 2 units in this direction. This is 2i. Plus 2j. What does this tell you? Again, j gives you direction. Go in this direction. By what magnitude? 2 units. This is 2j. What does this tell you plus 2k? It is also a vector. From where you stop here, go 2 units along k direction. K direction is out of the plane of the screen. Like this. So that vector will be in 3 dimensions, 2 in right direction, 2 upwards, and 2 out of the screen. We will come to that point. Magnitude of a vector. So as I was just telling you, a vector has any vector, every vector quantity has these two things. Magnitude and direction. Okay. If a vector is given in component form, like xi plus yj plus zk, how can you find its magnitude? How can you find its magnitude? Right. See,
So once can you scroll up? So 1 minute. Sir?
hmm.
Sir, here you wrote component vector, no, sir?
Component form.
Yes, sir. Sir, that means is it like a position vector?
If I am representing position using that vector A, it is a position vector. If I am representing velocity, it is a velocity vector. Acceleration, this acceleration vector.
Okay, sir.
Magnitude of a vector. I have a vector like this. This is one vector. What is this? Okay, I will write it like, say, vector A. This is vector A. How can I express vector A in component form? It has some value along x direction, I direction. It has some value along j direction. So I will write it
xi
like
plus
xi
yj, sir.
plus yj. Xi plus yj. That x is this. Magnitude of vector A along x direction is this. And that y is this. If this is y, this is also y. Okay. Using this x and y, can I write magnitude? If you remember, if I told you that if you are representing a vector by arrows, then length of the arrow gives you magnitude, and the tip of the arrow gives you the direction. So here magnitude means value. It's numerical value. Suppose if I write a vector like 3 meter I cap, all right, just right. So this is a displacement vector. It tells you this is some vector p is equal to 3 meter I cap. So this tells you that the magnitude of this vector is 3 meter and this direction is along I. Our vector q is equal to minus 2j. Magnitude is 2. Magnitude is not minus 2. Magnitude cannot be negative. Magnitude is 2 and this direction is along negative y-axis, minus j. Okay. So that's what we mean by magnitude and direction. Here also, vector A has magnitude x along I direction and magnitude y along j direction. Now, if I write the magnitude of vector A, these are magnitudes along individual directions, like this and like this. Okay. But I want magnitude of this vector, or say, in other words, length of this arrow. Length of this arrow. Then can I write it like magnitude of vector A is first of all it is represented by, it is represented as mod vector A. Mod, how do you read this? Mod, or its complete thing is modulus. Modulus of vector A. This is how you should read it, or in shortcut mod A. So if you put a vector quantity between two lines like this, it indicates that you are writing its magnitude, mod A. And how much is mod A? Mod A can be written as root of x square plus y square. How is this? This is nothing new. I hope everyone knows Pythagoras theorem.
Yes, sir.
If this is side A, this is side B, then this is the hypotenuse. Hypotenuse will be sum of squares of the two sides, a square plus b square. Okay, or let us say this hypotenuse is c. So c square is equal to a square plus b square, Pythagoras theorem. Or c is equal to under root this. I'm using the same thing here. In place of a, you have x. In place of b, you have y. And this is the hypotenuse c, which is a magnitude of vector a. So c square will be equal to x square plus y square, or x square plus y square, or c is equal to root of a square, x square plus y square.
Sir,
Nothing but the magnitude of vector a.
excuse me, sir.
Mm.
Sir, if the problem is solved again, that means A is equal to x plus y only, no, sir?
A is equal to x plus y. How do you get?
If we cut the square root, sir.
To cut the square root, you should take square here. How can we cut the square root? Root of x square plus y square is not equal to x plus y. Root x square is equal to x. Root x square is equal to x. Root y square is equal to y. Root x square plus y square is not equal to x plus y. You cannot cancel the square and square root because they are in addition. Okay. So if you see a vector like vector A is equal to xi plus yj, and if you are asked to tell its magnitude, then this must be your answer. Xi plus yj. If vector is xi plus yj, magnitude is root of x square plus y square.
Sir,
Okay.
magnitude of any vector is the same.
Yes. If vector B is equal to xi plus yj plus zk, three-dimensional vector, then magnitude of vector B magnitude of vector B is root of x square plus y square plus z square. In three dimensions, you will get the same thing.
Sir,
Mm.
sir, that means we have to square the magnitudes.
In each direction and add them.
Okay, sir.
Vector P is xi minus yj plus zk. Then magnitude of vector P is root of x square plus minus y square plus z square. Minus y square is again positive because you are squaring. So it will again be x square plus y square plus z square. If vector q is minus xi minus yj minus zk, then magnitude of vector q will be minus x square plus minus y square plus minus z square, which will again be root of x square plus y square plus z square. So whether you have plus or minus in the vector, magnitude will always be positive. A vector A is I plus 2j plus 3k. Then magnitude of vector A is root of 1 square plus 2 square plus 3 square, root of 1 plus 4 plus 9, root 14. B is 2i plus 3j plus 2k. Then magnitude of vector B is root of 2 square plus 3 square plus 2 square. 4 plus 9 plus 4. 8 plus 9, root 17. Like this, you can find magnitude of any given vector.
Sir,
Yes.
sir, if the magnitude value is same for all the three vectors, can we use root 2a, where a is the value of the magnitude?
A is value of the magnitude. Okay.
Sir, because this is same as the formula for diagonal of a cuboid.
Diagonal of a cuboid. Yes, just a
Yes.
minute. So if, let's say you have vector C is equal to some 2i plus 2j plus 2k. That will be root of 2 square plus 2 square plus 2 square, which is 3 times 2 square, 2 root 3.
Yes, sir.
2 root 3. Okay. So magnitude of a vector, is this thing clear?
Yes, sir.
So that is 18, no, sir? You wrote 17.
8 plus 9. 8.
17.
It is 17 only, sir.
Okay, sir.
Just a minute, I will.
Sir,
Yes.
sir, now for example, you took ijk value what, sir?
I took ijk values.
1, sir.
Root of 1 square plus 1 square plus 1 square, root 3.
Sir, x, y, z values are constant, sir. X is 2, y is 3, and k is 4. Like that, fixed value, sir.
You can take any vector. Take any value, any vector. To get magnitude, you should square each thing.
One minute, students. 1 minute.
Yes. So like this, you can find the magnitude of any given vector. Important thing, finding magnitude. Next, magnitude of a vector. Next is direction of a vector. Direction of a vector. We'll take two-dimensional vectors only for the sake of simplicity to understand easily. We'll take a two-dimensional vector, like vector lying in xy plane, and try to find out its direction. Suppose I have a vector like this.
Sir, by the way, could you explain again? So I did not understand.
See, if you specifically tell which topic you did not understand, I can elaborate on that. If I again repeat the topic, our class will be done.
Sir, why why different position vectors have a different value of sign, sir?
It depends on the position. It depends on its position. If I have something in the first quadrant, this is the first quadrant. I can represent it with
Yes, sir.
plus x plus y. If it is lying in second quadrant, it will be minus x plus y. You will get minus here. If it is lying in the third quadrant, it will be minus x minus y. If it is in fourth quadrant, it is plus x minus y.
Sir,
You can
then
extend this to 3 dimensions.
okay, sir. What does it depend on? Are there quadrants in 3-dimensional, sir?
It depends on the direction of that quantity, in which direction it is acting.
Are there quadrants or
They
something
are
like
not
that?
quadrants. They are not quadrants. You call them as quadrants in mathematics. Here, we are representing directions using ijk. Ij means this thing. Minus ij means this thing. Minus I minus j means here, you will come here. I minus j means you will come here.
Sir, but we are not having K, no, sir.
If you take k, you will go into 3 dimensions. I cannot show that on the screen. That's why I'm not telling you that.
Sir,
Right?
even K is also necessary, sir.
K is also necessary. That's why I have taken examples all in which are 3 dimensions here. Xi minus yj plus zk. I told you, if you remember in the last class, I told you to do this exercise. I don't know how many of you have done this. I told you to take one corner of your room as the origin and take this lying as x-axis, positive x-axis, this as negative y-axis, negative x-axis, this positive y-axis, this negative y-axis, this positive z-axis, this negative z-axis. And I told you to express the positions of different things in your room in vector form, like position of your switchboard, or position of sofa, or position of ceiling fan, or position of some what to call this, wall hanging, anything. Try to express that in ijk form. If you had done that, you could have got some clarity.
Sir,
Oh.
sir, I understood minus x-axis and y-axis,
Oh.
but the z-axis I didn't understand, sir.
How do you think is this coordinate system x, y, z axis? How do you think it will be? Can you see the three-dimensional coordinate system? Can you see z axis first of all?
Yes, sir.
How will it be? X axis is towards your right and towards your left. Y axis is, how is it?
Sir, up and down.
Up and down. How will be z axis?
Sir, slanting.
Northeast and
Slanting.
southwest, sir.
Z axis is not slanting. Z axis is towards you.
Northeast and southwest.
No. That is the mistake that many students do. Z direction is the third direction, no?
Perpendicular to the screen. Sir, into the plane and out of the plane.
Into the plane and out of the plane. 1 minute, I can take this. Positive z-axis will be coming towards you, negative z-axis will be going away from you in the screen. Can you get some idea from this? How the three coordinate axes look like? This is the x-axis, right? This is
Yes,
the
sir.
y-axis. Both are perpendicular to each other. And z-axis will be like this. It is not like this. This is x-axis, this is y-axis. We show z-axis like this. This does not mean that z-axis is lying between this axis and this axis. It does not mean that. As we cannot draw in
It
three
passes
dimensions on
through
a
those
screen,
axes.
Perpendicular to the y-axis, sir.
as we cannot draw in 3 dimensions on a 2-dimensional board, difficult to represent. So we show it like this. Actually, this is going into the plane of the screen and this is coming out of the plane of the screen, like here. Now, do you understand? Many students, I think 70-80% of the students make this mistake. Whenever a teacher draws z-axis like this, they feel that it is lying in between these two axes, which is wrong, absolutely wrong. You should try to look at it in 3 dimensions.
Sir,
Okay.
in that picture, why are x and y not perpendicular?
X and Y are perpendicular there. How are they not perpendicular? They are
Sir,
perpendicular. Huh?
In that picture, sir.
Yeah, in this picture, X and Y are perpendicular to each other. You are looking from a different point of view.
sir, Z is also perpendicular, sir.
Which one?
Z, sir.
Z is also, all the three are mixed. You do one thing, you take your left hand, all of you. You take your left hand. Close your little finger and ring finger and put your thumb, forefinger and middle finger perpendicular to each other. Put
Fleming's left hand rule.
like Fleming's left hand rule. Put your thumb, forefinger and middle finger of your left hand such that three are perpendicular to each other. Now,
Sir, can you repeat again?
1 minute. I will show this.
Even we can say corner of a room.
Yes, sir, that's what I told them, but I think they are not able to visualize it. See here. Here he has taken right hand, I think. Okay, you can take anything. You can take right hand also. Let us go with this picture. Put your thumb, forefinger and middle finger of right hand like this. And put your hand such that your middle finger is pointing towards you. Middle finger pointing towards you. Then your thumb represents X direction. Forefinger represents Y direction. Middle finger represents Z direction. Now is Z lying between X and Y? No, it is perpendicular to both X and Y. Right?
Yes, sir.
Now do you understand how does this coordinate system looks like? You understand how this X, Y, Z axes are?
Yes, sir.
Now if you imagine you are standing exactly at the origin and you try to look at X direction, that is the direction of I cap. Look at y direction. This is the direction of j cap. Look at z direction. This is the direction of k cap. And look at negative x direction. This is the direction of minus I cap. Negative y direction, minus j cap. Negative z direction, this which is into the plane, minus k cap. These are what ijk represent. Clear?
Sir.
Now, if I ask you what is the angle between I cap and j cap, what is it?
90.
90.
Angle between I cap and k cap,
90, sir.
angle
90, sir.
between j cap and k cap,
90, sir.
angle
90, sir.
I cap and minus I cap,
180.
180.
80, sir.
angle between k cap and minus k cap.
180.
180.
180.
A vector is like this. Vector A is like this. I can give its magnitude by root of x square plus y square. This is x, this is y. So its magnitude is okay. We have already discussed that magnitude of vector A is root of x square plus y square. But I want to give its the direction also, because let us say I'm giving you a position. I want you to start from origin and go to this point A. I am telling you the magnitude here, like it is some 100 meter. Let us say this is some 100 meter. So if I just tell you 100 meter, you cannot reach point A. 100 meter can be in this direction, here, here, infinite possibilities are there. But the point A which I am trying to specify here is this, which has a particular direction. How can we give that direction? I can give that direction using angle. Let us say this vector A is making angle theta with x-axis. Then I know x and y values. So if I write tan theta is opposite side by adjacent side in a right angle triangle.
Yes, sir.
Opposite side by adjacent side. Opposite side is y, adjacent side is x. So tan theta is equal to y by x. From this you can get the angle or you can get the direction. Let us say you get theta as some 30 degree, 45 degree, 60 degree. Depending on that, you can start in that particular direction and you'll reach point A. So we can write the direction, or we can express the direction of a vector in terms of angle like this using tan theta. Expressing magnitude and direction of a vector. Magnitude root of x square plus y square plus z square. Direction in terms of angle. You might be accustomed to writing directions like east, west, north, south, or northeast, northwest, southeast, southwest, vertically up, vertically down. These are not the only directions. There are infinite directions. So all directions cannot be represented only by northeast or west, southwest, or southeast. If I give this angle, value of this angle theta, then you can reach the direction and we can represent any direction using this angle theta. Theta can be 1 degree, 2 degree, 30 degree, 50 degree, 90 degree, 180 degree, 270 degree. I can give any direction in this plane. So these are two things regarding vectors, magnitude and direction. At least you do that exercise after this class. Select one corner of your room as origin. So fix x, y, z axis. Y axis will be the vertical one. Z axis will be the one which is towards running towards right, and z will be which is running in the third direction, perpendicular to both x and y. And try to represent right vectors which give you the positions of ceiling fan or a wall hanging or a switchboard, anything, any object that you see in your room. So try to do that, you will get clarity. You should be able to look in 3 dimensions. That is very important to understand vectors. Okay, right. So next after this we have, we should go for vector algebra, addition, subtraction of vectors. So tomorrow we will discuss addition of vectors. No, not before. Before that we have one more thing, resolution or components of a vector. After that we'll go for addition. Okay. Right. So that's all. See you tomorrow.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.
Thank you so much, sir.